All right, let's talk about some ideas from the past that you guys may have forgotten, which I want to remind you of. Here's some log properties. When you have a logarithm with any base and of 1, log base b of 1, that 1 there, log base anything, it could be log base here, log base 5 of 1, always equals to 0. We're going to use this today. Also, we're going to use when the base and the number match up, log base b of b, log base 3 of 3 equals 1. So these two are really important for us to know today, as well as the natural log of 1 equals 0, ln of 1, and ln of e. Remember how ln always has an e as a base? E equals 2.7, remember? So these are all things that we need to know for today. These two and these two, because we're going to graph logarithms and we're going to make a table of values, and I want to use small numbers like 0 and 1. So I need to transform and make it natural log of 1, natural log of e, log base something to a 1. So what that looks like is, all right, when I do this, I have my parent function. So here we go. Y equals log base whatever, base b, x minus h is my left or right shift, k is my up or down shift, right? Well, in this case, the h is my vertical asymptote. We have a vertical asymptote. And here's a fun way to remember it, LOG. See how I made a vertical asymptote with the L, with my dotted line? So there is a fun way to remember that in logarithmic graphing, we have a vertical asymptote, not a horizontal asymptote. The domain is going to be the h value and then infinity, and the range will be all real numbers. I put this box here because it's really important for you to know. I've got log base b of 1 equals 0, log base b of the same number equals 1. So first two we're going to use. I need to pick values for x. I'm going to graph and I'm going to make a table of values, but I don't know what values of x to choose. I have to look at my parentheses to help me figure out. So here's what that means, is I want my parentheses that has the x in it to equal the base, and I also want it to equal 1. Okay, so what that means is that I'm going to look, and I'll write my two important rules. Log base b of 1 equals 0. Log base b of b equals 1. I'm going to write my two important rules on top. I need my parenthesis right here. This says log base 3. I need my parentheses to equal a 1. So I'm going to set the parentheses equal to 1. And I need my parentheses to equal 3. So I want my parentheses to equal 3 because then I'd have log. So if I pick 3 as an x value, I'm going to get log base 3 of 3. Hey, the base and the number are the same. That is right here. That gets me a 1. So then, yeah.
So in order to get 1, you have to think of a number that makes it 1.
That matches the base. Yeah. So I also want log base whatever, and I want there to be like an actual 1. Log base 3, and I want there to be a 1 right here. I'm going to put x equals 1. Because then I have this. Log base 3 of 1. Look at log base whatever of 1. That equals 0. This is a rule, a property of logarithms that we're going to use to make our graphing super easy. So you're literally looking at the parentheses and saying, well, I need it to match the base. So pick a 3. I also need it to become 1. So put a 1 in. Now, my vertical asymptote is, what's my h and k? Well, there is no h. This is like x plus 0. So 0 is my vertical asymptote. I'm going to draw that right here. My ordered pair is 3, 1 and 1, 0. All right, here we go. So 3, 1, over 3, up 1. And then over 1, up 0. The shape of a logarithmic graph looks like this. It gets really close to that vertical asymptote and it never touches. Now, what if my equation was this? So graph, what if I had like a 2 in front? Well, that would just be like 2 times log 3 of 3. 2 times 1. The 2 is just something that gets multiplied. Or 2 times log base 3 of 1. That's 2 times 0. So the 2 could be in front as an a. Remember the a? I could put a coefficient in front. My domain is 0 to infinity because x is 0, my vertical asymptote. Range is always all real numbers. Okay. Now, I need the x plus 1 to match my base. I need my x plus 1 to match my base. My base is 2. So I'm going to go x plus 1 equals 2. So what value of x should I plug in to get my parentheses, x plus 1, to equal 2, which is my base? X equals 1. Okay, that's a number I'm going to put in. Also, I want my x plus 1 to equal 1. Remember, I want it to be a 1 and the same base. I think you could probably think of these in your head. You might not need to write out this little teeny binomial. Okay. So let's plug it in. Log base 2 of 1 plus 1 minus 2. Is log base 2 of 2, which we know is 1, right? Same base, same number. Log base 2 of 2, that's this rule right here, it equals 1, does it not? 1 minus 2, negative 1. My first order pair is 1, negative 1. Next, log base 2, 0 plus 1 minus 2. Okay. Log base 2 of 1, which we know log of any base of 1 is 0. 0 minus 2 is negative 2. So I got 0 and negative 2. My vertical asymptote is my h. X equals negative 1. So I'm going to graph that. X equals negative 1 is my vertical asymptote. And now I can graph my ordered pairs. 1 comma negative 1 and 0 comma negative 2. So those are 2 logs. And guess what? The next 2 we're going to do are going to be natural logs, and it's just as easy. My domain is negative 1 and infinity. My range is all real numbers.
Miss Grant,
Yep.
so can K work like how it like regularly works? So like be like shifted up or down, or like
Yeah. K brought me down 2. Look, down 2. See where my, so the K, but we don't do H and K first. No, 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 we don't.
okay.
We have to do an order, a table of values for this one. All right, natural log. Here's the 2 rules we need to know for natural log. I want my X value to be an E because when it is, it equals 1. I also want my X value to be a 1 because then I get a 0. I'm picking these small numbers because they're the easiest to work with. Okay. So here we go. ln of X. This is just basic. Instead of X, I want there to be an E. E equals 2.7. Instead of X, I want there to be a 1. So let's do this. If for my X value, I plug in an E, which is, 2.7, I will get ln of E. What's ln of E? What is it?
It's 1.
It's 1, which means I now have an ordered pair 2.7, comma 1. And what if I had like a 3 in front? 3 times ln of X. No problem. You just multiply 3 times ln of E. 3 times 1. Okay, there could be a number in front, it doesn't matter. I want ln of E. I also want natural log 1. So I'm going to put a 1 there, and it's going to be ln of 1. What's ln of 1? 0. My ordered pair is, I'm sorry. My vertical asymptote is again X equals 0 because there was no H. Then my points, 2.7 comma 1 over 2.7 up 1 and then 1 comma 0. So it looks like this. Downward, it never touches the vertical asymptote. Gets really close though. Okay. Now, ln of x minus 3. How do I get the x minus 3 to equal e? Well, 2.7. I need x minus 3 to equal 2.7, which is e, right? So you're going to set the parentheses equal to 2.7. And I have to figure out what number should I plug in? So that's going to be add 3 to both sides. X is going to be 5.7. So I'm going to put as my X value 5.7. Then when I do ln of 5.7 minus 3, I'm going to get ln of 2.7. Natural log 2.7, which is e, which is 1. ln of e, what is it? It's 1. So look carefully how I did this. I also want the parentheses to equal 1. Remember how I want ln of 1? ln of 1, I want this whole parentheses to be a 1. Something minus 3 is a 1. What minus 3 equals 1?
4.
4. 4 is what I'm going to put in for x. 4 minus 3. ln 4 minus 3. ln of 1. What's ln of 1?
0.
0. Ooh, I have a fun vertical asymptote this time. X equals positive 3. That's my h. H is 3. Mark your horizontal asymptote. And now, I'm sorry, whoa, vertical asymptote. And now, 5.7 comma 1 over 5.7 up 1. And then 4 comma 0. Looks like this. All right, so I'm going to stop the recording.